Well, good day to you and welcome back. Well, so we've talked on this channel about character spacing, how many characters per inch the typeface is. We haven't talked so much about vertical spacing or line spacing, and I thought it would be a good time to do that today. So typewriters get a lot of their technology from the printing press world, which of course preceded typewriters by hundreds of years. In the printing press world, using imperial measurements, they had a unit of measure called point size. And point size was like the vertical height of characters. And they had a system in place where 72 points to an inch. It gets a little confusing now because the terminology is used in various ways between the printing press world and the typewriter world. But in the printing press world, they had a unit of measurement that was 12 points high, and they called it a pica. It was the height of a character. And as it turns out, there are 6 picas to a vertical inch in a printed page or a typed page. So each pica being 12 points high, and 12 times 6 is 72. So this became a common standard for typewriter line spacing, 6 lines to the vertical inch. However, it's not the only standard, as we shall see. In fact, in the small sampling of typewriters that I made from my collection, I counted 3 different line spacing standards just amongst the 13 machines that I checked. So in various typography catalogs, you'll also see made mention of picas referring to widths of characters, and those are actually the same units, 12 points wide, which is like 1/6 of an inch. So if pica is referring to a size of letter in terms of width, it's 1/6 of an inch. If it's referring to the height of a letter, a pica is 12 points high, which is also 1/6 of an inch. And there can also be pica typeface styles that aren't necessarily either of those sizes in height or width, but they are called pica. So we're going to talk about vertical line spacing today and typewriters, and I learned some interesting things that I'd like to share with you. Please stay tuned. Okay, so what I wanted to do is find out how to test the actual line spacing of each machine. I started with this piece of paper. This is newsprint paper, so it's slightly off-white. And I started with the Praxis 48, and I started near the top of the page, and I set each machine to single line spacing, and I typed a dash the entire length of the page down close to the bottom. Some of them I stopped a little bit short of. So then also at the bottom, I've written in red ink the number of teeth on the line spacing ratchet, and I've also written in red ink whether it's a half line machine or a full line machine, meaning a half line machine as each click of the line spacing ratchet is half a line. So single line spacing does 2 clicks, whereas a full line machine, like most American machines like these Smith Coronas here, would be 1 click is 1 full line. So I tested the Praxis 48, the Olympia SM9, the Hermes, this SM9 is from 1978, by the way, a Hermes 3000, this was the middle body style. 2 Smith Corona Silent Supers. One of these, this one here, was supposed to have a new platen, a recently replaced platen. We'll talk about that later. The 2 Silver Seiko Japanese-made machines, the Royal Mercury and the Electric Royal Saturn. And then the Remington 1040 made in Holland, the Olympia Splendid 33, the Princess Exemplar 300 made in Germany, the Hermes Rocket, the Groma Calibri, and finally the Royal KMM. So those were all the machines that I actually tested. So of these machines, almost all of them, except for 2 of them, have the 6 line per vertical inch spacing standard. And the 2 that are different are the Hermes Rocket and the Groma Calibri. We'll look at those in a little bit later. And to make the columns of dash marks, you have to set your typewriter to single line spacing, make sure the paper is straight in the machine, start near the top of the paper, and simply go dash, carriage return, dash, carriage return, dash, carriage return, all the way down the bottom of the paper. Let's start with the Praxis 48 just for example. If you want to know what's the nominal line spacing supposed to be on my typewriter, just type a series of single space dashes and then measure them, and you can see for the first inch that it is nominally 6 lines per inch. And that's true with 11 of the 13 that I tested. They were all 6 lines per inch, and you can see that pretty easily. Just zooming in closer, you can see the first inch here, from here to here, there are 6 lines. So that tells you the nominal spacing of what it was intended to be. However, once you zoom out and look at the entire line, you can start at the top here on your left, and you can go down to, let's say, 9 inches is reliable, because some of these ended before you get to the 10th inch. But if you go out 9 inches now, if the line spacing is exactly 6 lines per inch, then at the 9th inch, you should be even with the 9-inch mark. And what I've done here is I have marked in red ink where the actual 9-inch point is on every one of these. So as we can see here, in fact, we'll use the same pen, this Praxis 48, the 9-inch mark is a little bit beyond the dash, which means that the platen is a little smaller than it should be. It's not actually 9 inches in feed. The SM9 is almost exactly right on the mark, and so that is probably because this is a machine built in 1978 and it's just newer. The Hermes 3000 is pretty close. It's just a small fraction under the 9-inch mark. So the two Smith Corona Silent Supers both look shrunken from the 9-inch point, and oddly enough, the one that's supposed to have the newer platen looks more shrunk than the older one. We'll talk about that in a little bit. And then both of the Silver Seiko machines, the Royal Mercury and the Royal Saturn, pretty close. The Mercury looks a little bit smaller already, and the Saturn, however, is right on where it should be. Now, I don't know if this means that in the year or so since I had the Mercury done, it's actually shrank, or perhaps it wasn't really made to the exact same standard size as the Saturn was. And again, this is J.J. Short and company that does this, and they don't have the typewriter with them to know what the standard is. So I don't know their business process. And this is one of the issues, is it's proprietary, of course. They're one of the few companies in the United States that offers this service. So I don't know the way they do things, but it looks like these two platens were replaced within a year, probably within 6 months of each other. They're the same standard, or should be the same size, but you can see at least one of them looks a little bit shorter than the other in line feed. Keeping in mind, though, this could also be related to other factors besides just the platen diameter. It could be how well the feed rollers are gripping, etc. Right, because there is more to line feed than just the platen alone. Okay, the Remington 1040 was a little bit short of the 9-inch mark, unsurprising. The Splendid 33 was pretty darn close, actually, as well as the exemplar Princess 300. It was almost dead on the 9-inch mark. And then we get to the Hermes Rocket, and it's a different line spacing standard. It's 5.5 lines per inch instead of 6. It's pretty close, as well as the Groma Colibri. It's actually pretty close, and it has a 5.75 lines per inch standard. And then the KMM is actually fairly off, probably is indicative of the age. I'm sure it had a new platen since 1920, but it's been probably decades since that was replaced. Well, so what I wanted to do is figure out if I could calculate what the ideal platen size should be for any of these machines. So if you look at the cross-section of the platen, it's a circle, and it has X number of teeth. And I've decided to call the total number of teeth on the platen T sub A, is all teeth. Okay? And that'll vary from one machine to the next, and I've tabulated this in a table, which I'll show you in a minute. So I figured out that you could make a ratio. You could say 360 degrees around the platen is proportional to that number of teeth, and 1 inch of circumference. In other words, when the paper is fed 1 inch along the circumference, that's proportional to the number of teeth for 1 inch, which I'm calling T sub P. So you have this ratio between the total number of teeth on the platen's sprocket gear and how many teeth it uses to feed the paper 1 inch. And it turns out that if you transmutate that formula and do a little bit of simple arithmetic, you can come up with this ratio, all the teeth divided by the number of teeth for 1 inch times pi. This is the diameter of the platen in inches. So you might be wondering, how do I measure the number of teeth on my line spacing sprocket on my typewriter? How do I do it easily? Well, what I did was I put a reference piece of tape on the frame of the carriage next to the sprocket with a mark on it, and then I put a thin piece of tape with a mark on it lining up to one of the sprocket teeth. Make sure those two pieces of tape, the lines, are even with each other to start with, and then I simply turn the platen by hand 1 click at a time and count the number of clicks until it comes around again and lines up again to the reference line. That's how I counted all the sprocket teeth on all 13 machines. So what we have here is I have each machine listed on the first column, and then I have the number of teeth on its line spacing sprocket, and then I have the line spacing standard for that machine. How many lines per vertical inch or per inch of line feed? You'll notice most of them are 6 lines per inch, and there is the two oddballs, the Hermes Rocket at 5.5 and the Groma Colibri at 5 3/4. And then I have here whether or not it is a half or a full line spacing machine, meaning when you put it in single line spacing mode, is there 1 click or 2 clicks? Does each gear tooth represent a half a line or a full line? And then the next column is a number of teeth per inch of line feed. And what this is essentially this column divided by this, meaning if it is a half line machine, it's going to be 2 clicks. So 6 times 2 is 12. If it's a full line machine, it's 1 click for a line, and that's 6 times 1. So this is the number of teeth on the line spacing sprocket for 1 inch of line feed. And then, based on this formula that I just showed you, we can calculate what the diameter should be. Here is the actual measured results. So in this comparison of 13 different machines from my collection, 2 of them were Smith Corona Silent Supers, and one of those Silent Supers, which on my list is, I'm calling it number 2, that particular machine I had gotten the platen recovered back in 2019 by J.J. Short. And when I made the measurements here, I calculated what the diameter should be, 1.273 inches, and I measured it at 1.265, and I thought, oh, that's kind of like it's shrank quite a bit since then or whatever. And then after I made this table, I looked at the platen more carefully, and it looks like it's an old platen. So that's interesting because, okay, so the Silent Supers and the Silents in the 5 Series Smith Corona line were the typewriters where you can easily pull the platen out. So I went through all my other 5 Series machines, including my electric 5TE, to make sure that I didn't, by mistake, take that newer platen and put it in another machine. And evidently I have not. So that leaves one of 2 possibilities. One is either that J.J. Short platen in 5 years has aged considerably, where it's just as hard as an old, 40-year-old typewriter, 50-year-old typewriter, which I kind of doubt. Or perhaps at a public typewriter event, the platen got swapped. I won't go any further into that possibility because I can't really prove it. But all that to say, I was looking at the numbers thinking, why is this Silent Super that's supposed to be a newer platen not any better than the other Silent Super with a really bad platen? So that's the explanation. So just going through the results here. So the Praxis 48 has the largest diameter platen at 1.6 inches, and it measures within 1/100 of an inch. The SM9 measures at 1.268. Ideally, it should be 1.3. So Hermes 3000 is pretty close, within 1/100 of an inch. And then all of these, the Smith Cornell Silent Super all the way down to the Hermes rocket, all have a calculated diameter of 1.273, and their actual diameter is within 1/100 of an inch or so. Actually, the Remington 1040 was the only one that had a diameter that measured larger than the calculation, 1.274 versus 1.273. But keep in mind, this is probably related to the accuracy or repeatability of my measuring instrument, the calipers, and how I was doing it, because a thousandth of an inch is pretty dang small. And also, I would point out the Exemplar 300 Princess is also measured right at the number it should have been. So within the tolerance of my measurements, it's not scientific, but trying to be as consistent as I can, they were all pretty close. Then the Groma Colibri had the smallest platen. It calculated out to be 0.996 inches, and it measured at 0.990. So it's essentially very close to the same of what it should be. And then the KMM was off by maybe 1/100 of an inch also. And it's pretty hard. Its platen is pretty hard for sure. The condition of the platen has a lot to do with your line spacing, but also your feed rollers have to do a lot with how well it spaces, how consistently it spaces. I didn't really talk much about consistency of spacing, but studying the chart of all 13 machines that I tested, that there is some variability in line spacing as you go down for some of these machines. I should also point out that another source of variability in line spacing, which isn't that common, but I have seen, especially my friend Kevin has seen, is the line spacing ratchet teeth themselves can get worn down. And we've seen on at least one machine where it wouldn't reliably, the spring-loaded roller that's supposed to ride in between the teeth, it wouldn't reliably ride into the teeth properly, and it caused irregular line spacing. And what Kevin had to do is actually carefully file down some of the teeth to make them sharper, and that actually helped the line spacing. So platen diameter isn't the only thing that can affect line spacing. So how does this line spacing study affect you? That's a really good question. And I think if you're using just one machine, or using individual machines by themselves, it doesn't really matter that much. But the only way it really does matter, there's a couple ways. Number one is if you are making a document with multiple typefaces. So you're going to take a partially typed page out of one machine, put it into another machine that has like a different typeface. So you might want to have really precise line spacing between both machines. The faces of the type slugs are curved, and they're designed to curve to a certain radius of platen or certain diameter of platen to get the best quality imprint. So it's possible that a shrunken platen, you will get a poorer imprint just because the full impression of the letters isn't giving equal pressure onto the paper because the platen is too curved for the curvature of the typefaces. So that could be a quality issue that's hampering you from having really good quality imprint on your machine. However, I do think it's useful for you to be able to calculate what the ideal platen diameter is of your machine. So then you can measure the platen with a pair of calipers and figure out how much it's shrank. And also, if you're a do-it-yourselfer and you want to pull out the platen and cover it in heat shrink tubing, this might give you an idea of how thick the heat shrink tubing needs to be to get back to the original diameter of the platen. I think that's probably the most useful part of this formula that I shared with you. If you go to the Typewriter Database, and you have to be a member, you have to sign in. And if you sign in to the database under this link up here at the top, this down arrow link, you'll see typographical. Click on typographical, and you'll have a library of old typographical resources for typewriters. And the one that I found was very interesting was this Drusic Typeface Catalog 1957. When you click on it, it'll download it to your computer. Near the top of the catalog on page 5, you'll first of all see a diagram of a typical typeface, and they're showing you all the measurements. So what they call S is the width of the slot that the type bar fits over into the slug, and then M is the motion between the center of the uppercase and center of the lowercase letters. L is the length of the type, or basically the height of it from the top to the bottom. K is the width of it, etc., like that. So those are the terminologies that they are using in the catalog. On some of these typefaces, they're going to list the spacing and the motion in millimeters. But for others, for instance, these Remingtons, they're going to list the spacing in inches, fractions of an inch, and the motion in millimeters, because the letter spacing on these typefaces are conforming to tenths or twelfths of an inch versus European typefaces that are conforming to a metric standard. So you notice they're mixing both metric and imperial. So now I've picked a typical typeface. This is UT3 Pica, and what I want you to pay attention to is right here on the left side of this chart is R equals 22 millimeters. This is the radius of curvature of the typeface. In other words, the face of the typeface is curved. This is the radius that it's curved to. So twice that, which would be 44 millimeters in this case, that will be the diameter of the platen in millimeters that it needs to conform to. So if you can find your typeface exactly of your typewriter in this chart, it'll tell you the diameter that the platen needs to be. Okay, also available on the same section in Ted Monk's website is this print magazine. And near the back of it on page 60 is a list of Remington typefaces. And you'll notice on the right-hand column over here, it lists the vertical spacing in lines per inch. And you'll see many of them are 6, but there's also 5.4, 5, 3, 3, 8, 6, 6, 5.4, 5.4. A lot of older Remington typewriters, they mostly had 6 lines per vertical inch, but there were varieties of those as well. Well, I admit, yes, this was a geeky video. It's going to bore a lot of you guys who are just interested in how can I use my typewriter to write with. A lot of this knowledge here you don't really need for anything practical or creative, but it might help you in maintaining your collection better and making some choices about what kind of typewriter you'd like to buy. In any event, I wish you the very best in your creative pursuits. And as always, stay creative and have yourselves a great day. And bye-bye for now.